Most fan clutches produced by Horton before 2001 are what we call S or HTS style fan clutches. S and HTS style fan clutches are air engaged. This means that when the fan clutch is in its resting state without air being supplied, it is disengaged. Only when you add sufficient air pressure to the fan clutch will it engage. When the thermoswitch senses the engine coolant temperature is above specified levels, it sends a signal to the solenoid valve. The solenoid valve opens and sends air to the fan clutch. Air travels through the body of the fan clutch and forces the friction plate, which is attached to the fan blade, to engage with the pulley. This causes the fan blade to rotate with the pulley, and the fan clutch is engaged. Once the thermoswitch senses that the coolant temperature has returned to specified levels, it sends a signal to the solenoid valve to shut off the air supply. With no more air pressure forcing the friction plate against the pulley, a spring pushes the friction plate away from the pulley to disengage the fan clutch. This is air engaged and spring disengaged. The term S-type stands for slip type, while HTS type stands for high torque slip type. The difference between S-type and HTS type is the diameter of the friction plate and the friction material. The friction material and friction plate in an S-type fan clutch has a 7.5-inch diameter. The HTS type fan clutch has a 9.5 friction plate and friction material. An S-type fan clutch can be rebuilt with the Kitmaster's part number 7500 HP, and the HTS type fan clutch can be rebuilt with the Kitmaster's part number 9500 HP. All air-engaged fan clutches can be rebuilt with either the 7500 HP or the 9500 HP, and all you have to do to determine which one to use is measure the diameter of the friction material or friction plate, or take note of the first 3 digits of the OE part number. If the third digit is 0, it is a 7.5 and will use a 7500 HP. If the third digit is 1, then it is 9.5 inches and will use a 9500 HP. For example, part numbers that start with 790, 990, and 980 all take the 7500 HP, and 791, 991, 981 all take the 9500 HP. The only exceptions to this rule is the rare 9-inch single plate. In this case, the friction plate will measure 9 inches and the part number will begin with 9908. These clutches require kit number 94207. The other exception is also rare, but some 9.5-inch friction materials are specifically designed with an extra thick backing plate. If you see an extra thick backing plate on the 9.5 friction material, you will need to use Kitmaster's part number 9505 SP. There are 3 primary causes of failure in this type of fan clutch: air leaks, bearing failure, and friction material failure. Kitmasters has engineered solutions for each of these primary causes of failure. In an air-engaged fan clutch, where 90 psi is required to engage the fan clutch, air leaks are the #1 cause of failure. Air can leak from the fan clutch in multiple places. The most common place is through the bleed hole on the top of the nose cone. However, it can also leak at the connection point between the nose cone and friction plate, the gap between the friction material and the friction plate, the come-home holes, or the fuse on the friction plate. To solve all these air leak issues, Kitmasters engineered the HP kits with Viton O-rings instead of NBR O-rings. Using Viton in an O-ring increases the operating range to 400 degrees Fahrenheit versus 250 degrees. It also adds lubricity to the O-ring, which makes the O-ring more resistant to drying out. There are 2 sets of bearings in this style fan clutch: pulley bearings and splined hub assembly bearings. Most of the bearing failures that occur happen in the splined hub assembly. The splined hub assembly has to absorb both the radial load from the fan belts and the axial load from the fan blade. The dual load causes stress on the bearing and may lead to premature failure. Kitmasters engineered our splined hub assembly to solve this common cause of failure by adding a second bearing. OE splined hub assemblies contain only 1 bearing. We added a second bearing to the back of the hub to transfer more of the load further down the shaft, creating more surface area to absorb the loads and reducing wear on the front bearing. The friction material is another common cause of failure. It most often fails in one of two ways. Either the friction material wears to the point that it can no longer be effective, or the friction material shears away from the backing plate between the friction screws. Kitmasters engineered our friction material to solve these common causes of failure by using dramatically stronger friction material. The result of this stronger friction material is that it can sustain more engagements before it loses its efficiency. We also use a spring-tempered bonding process. This means that as the friction is being bonded to the backing plate, there is a spring that provides constant compression until the bonding is complete. This process ensures that the friction will not shear away from the backing plate between the screw holes. Other less common causes of failure and their solutions are fuse failure, air cartridge leak. In an S or HTS type fan clutch, if the friction plate and the friction material slip, excessive heat will be created and may even cause an engine fire. The friction plate is designed with an air passage that is blocked by the fuse. If the friction plate is slipping and becomes too hot, the fuse is designed to melt and allow all the air to escape through the passage. With no air supply in the fan clutch cannot engage and therefore cannot slip. The bad news is there is no fan clutch and no cooling. The good news is that there is no engine fire. Kitmasters designed our fuse to be made of Teflon instead of lead. Teflon has a more specific melting point than lead, but more importantly, lead becomes softer slowly over time. Since the fan clutch does not stay engaged for more than a few minutes, it may take several slipping events to finally blow a lead fuse. With our Teflon fuse, the first time the fuse reaches the melting point, the heat simply melts the Teflon threads and blows the fuse, instantly creating the desired air leak. The benefit of this feature is that once a fan clutch starts to slip, it causes damage to all the other fan clutch components. The sooner you stop the slipping, the more of the fan clutch you save. You may be able to repair the air leak with a less expensive minor seal kit instead of a complete rebuild kit. Another potential failure point in an S or HTS fan clutch is an air leak around the air cartridge. The OEM uses two NBR O-rings sitting in one open groove to create the seal around their air cartridge. Kitmasters uses 3 Viton O-rings, each sitting in their own O-ring groove. We believe this provides a far more effective seal.